Exercise 7, number 4. Given triangle ABC and AC being 4 units. 4 units. And they tell you that tan A is actually 3/2. And the angle A is an angle between 0 and 90 degrees. That is obviously an angle in the first quadrant where all functions are positive in that quadrant. So basically it's anything between 0 and 90 degrees, that angle. Now, before we proceed, let's assign our sides. This is going to be my hypotenuse. Now, because we're talking about angle A, this side is going to be opposite angle A, so that's going to be my opposite side, and this side is the adjacent side. Now, again, I'm going to write the acronym SOA. They say they want the length of BC. They've given us 4 units there. Now, remember that the ratio for tan A is going to be is given as 3/2. But what is 3/2 in terms of our sides? Is the opposite side over the adjacent side. So the opposite side is actually what? Is actually BC. Beautiful. And then the adjacent side is now AC, which is actually given as 4 units. Now, we're not going to concentrate on the tan A. We're going to eliminate this. And then we're going to substitute the value of AC being BC over 4 units. Now, we're going to take this part and equate it to this ratio so that we can be able to find our BC. So that's going to be BC over 4 is equals to 3/2. Remember, that's a ratio. It could be any number. So that's 3/2. So we make our, pardon me, let me see. Yes, we make our BC subject of the formula. Well, good. And how are we going to do that? That tells me that BC to BC will be equals to 3/4, and then BC will be equals to 3/4, that's 12, divided by 2. Therefore, BC will be equals to 12 divided by 2, that's 6 units. Now let's see how true that is. Let's say it's 6 units. So in essence, 6/4, there's a relationship in this ratio of 2. So 6 is basically 3 2's and 4 is 2 2's. So this gives us exactly the relationship that was given by tan A. So BC is 6 units. BC is 6 units. Beautiful. Now we go to the second part. Second part, which is B, says B requires us to calculate or determine the length of AB. Remember, in this case, we already have 6 units and it's not even a rounded off figure. So, well, in this case, I can pardon you. We can use both the opposite side and the adjacent side to find the hypotenuse, because we didn't get a fragmented, or should I say, a decimal number that is going to cause errors going forward. So AB squared is going to be equals to AC squared plus BC squared by Pythagoras, and therefore we're looking for AB. AB will be equals to the square root of AC. We already substitute AC. 4 by 4 is 16 plus BC being 6 units. 6 times 6 is 36, and therefore AB will be equals to the square root of 52. Let's see if that's correct. That's going to be 16 plus 36, giving you 52, and the square root of 52 giving us AB will then be equals to 7.2 units. Beautiful. That was part B. So this is going to be 7.2 units. Great. And then part C tells us calculate the size of angle B. Now angle B is an angle right over there. Right. I suggest we use the sides that have got whole numbers rather than using a decimal number. Remember the risk that we spoke about. So when looking for angle B, this side changes, it becomes opposite, and then this side changes in relation to angle B and becomes adjacent. Now the hypotenuse remains the hypotenuse. Okay, well now the relationship there tells us that it's an opposite end and an adjacent side relationship, which is actually again your tan theta, your tan. Okay, so now what are we going to say? Your tan function is going to be tan angle B will be equals to opposite side being AC over adjacent side being BC, and these substituted will be AC is 4 units over adjacent side being 6 units, and that's going to be 2 over 3. Now tan B will then be equals to 2 over 3, and then B, angle B, will then be equals to arctan of 2 over 3, and that will therefore be angle B will be equals to, and punch that into the calculator, that's going to be arctan of 2 over 3, giving us 33.7 degrees. That's it for exercise 4.